and 3. Section 1.1 was solving linear equations. And what did linear mean? How do you identify? No, linear. Linear is first degree. The highest power is x to the first. Today in 1.2 and 1.3, we're dealing with quadratic equations, and you do need to know that that means second degree. So if you have an equation whose highest power, or the term of the highest power is x squared, then you're looking at a quadratic equation. You need to know that standard form of a quadratic equation is just to have it in descending order and set equal to 0. It doesn't matter which side your zero's on, but standard form is descending order and set equal to 0. Now, a couple of these methods, I'm just going to show you good examples in the book, because if something's written beautifully well in the book, there's no point in us copying it down in class. When we get to this third method, I'll start doing some examples in class. But the first method is by factoring. And on page 93 and 94, you have a couple of good examples I want to show you. You'll remember this from somewhere. Example 1, part A, x squared plus 6x equals 0. The first thing I have to think is, hey, that's a quadratic equation. On the test, the quadratics are mixed with the linears, and you have to look at each one and know what kind of equation it is to know what to do next. So the first thing you have to think is this is a quadratic equation because of the x squared. The next thing you need to think is, well, this one's already in standard form because it has a 0 on one side and the other side's in descending order. As soon as you think this is an equation in standard form, your next thought has to be, so there are 3 ways to solve it. Either I can factor or use the square root method or the quadratic formula. It is my opinion that if you're a good factorer, factoring's the easiest way to do it. Now, some folks aren't good factorers and they prefer to do everything by the quadratic formula. That's okay. It'll just take you longer. So let's talk about this factoring method. If you multiply 2 things together and get 0, what has to be true about one of them? One of them has to be 0. That's the only way you can get 0 as a product. So if you can factor this, and here all you can do is factor out a GCF of x, but if you can factor it and it's set equal to 0, then one of the factors has to be 0. Just set each factor equal to 0 and solve those 2 equations. This carries on into the next page. You set the x equal to 0 or the x plus 6 equal to 0. X equals 0 is already solved. That's one of your solutions. The other solution is obtained by subtracting 6 from both sides. So your 2 solutions are 0 and -6, and you can check them just by substituting them one at a time back into the original equation. If you let x be 0 in the original equation, you would have 0 plus 0 equals 0. That's certainly true. If you let x be -6 in the original equation, you'd have 36 minus 36 is 0, and that's also true. So that problem was very easy to solve by factoring. The part B is also a quadratic equation, but this is not in standard form. I have to have it in standard form before I can try to factor it. So the first thing I did, or the book did, was subtract the x and subtract the 3 from both sides to get it in standard form. And then here's where your factoring skills come in handy. You say, that's the hard kind of trinomial. Some of you factor it by grouping, some of you by trial and error. Whichever method you use is fine. But whenever you factor, you need to check your factoring before you go any further. Just multiply that back together really quickly to make sure it gives you what's on the line above it. And if your factoring checks, then you're ready to take it apart and set each factor equal to 0. And you solve those 2 equations. The first one, you add 3 to both sides and then divide by 2. The second, you subtract 1 from both sides. And you get the 2 solutions -1, and +3/2. So the reason I'm not writing down any examples of the factoring method, number one, I think it's probably the method that you're already most comfortable with. And number two, you have those two great examples in the book. Just make sure your quadratic equation is in standard form, and then factor. Before you go any further, check your factoring, and then set each factor equal to 0. So let's talk about the second method. Yes, sir. It doesn't matter. If I said I have 3 children, I'm not specifying what order they came in. If I say Emily, Mallory, and Haley, you're just saying these 2 answers work, and it doesn't matter in what order you write them. My math lab should have no problem taking that in either order. All right, so let's say you are faced with a quadratic equation that won't factor. Not all quadratic equations will factor, and as a matter of fact, probably most won't factor. But if it will factor, in my opinion, that's the easiest way to solve the equation. If I'm faced with one that won't factor, the next thing I try is the square root method. The square root method just says if you can get something squared by itself, the x squared by itself, then you can unsquare that x by taking the square root of both sides. Taking the square root of both sides is a legal thing to do to an equation, as long as you remember something. Now think about this. If I had x squared equals 9, and I just came up to you one day and said, hey, what can you square and get 9? The first thing that would pop in your head is 3. But is 3 the only thing you can square and get 9? No, what else can you square and get 9? -3. So when you take the square root of both sides of an equation, you have to remember both the positive and negative square root. And that will give you both answers. When you take the square root of both sides of this equation, you do get the positive square root of 9, which is +3, and also the negative square root of 9, which is -3. So once again, if I'd brought my gold pocket watch, I would hypnotize you so that whenever you thought the words, take the square root of both sides, immediately after that, you would think, ooh, don't forget the plus or minus. There are also 2 very good examples of this method in the book. So I'm going to show you those on page 94. The A part's the simplest, just x squared equals 5. It's a quadratic equation. It has x squared by itself, so all you have to do is take the square root of both sides. Bells and whistles go off to remind you what? Don't forget the positive and negative. Don't forget the plus or minus. Now, you can't simplify square root of 5 like you could simplify square root of 9, so just leave it as an irrational number. Your solution set is positive square root of 5 and negative square root of 5. It doesn't matter in what order you write them. This B part's a little bit different, though. You may not even think at first, hey, that's a quadratic equation, but if you multiplied x minus 2 times x minus 2, you would get an x squared. That's why it's a quadratic equation. And you can multiply that out and then subtract 16 from both sides if you want to get it in standard form to see if it'll factor. That would not be illegal. It would just not be the most efficient thing you could do. A more efficient thing is to recognize, hey, this is just something squared by itself. Anytime I had something squared, it doesn't matter if it's a plain old x squared or an x minus 2 squared. If it's just something squared by itself, I can take the square root of both sides. The square root of x minus 2 squared is just x minus 2. Square root of 16 is 4, but don't forget the plus or minus. Now, the easiest way to finish that is just to separate that plus or minus and solve these 2 equations. Either x minus 2 equals +4 or x minus 2 equals negative 4, that gives you the two solutions, positive 6 and negative 2. And it doesn't matter in what order you write them. So, faced with any quadratic equation in the whole wide world, first thing I'm going to do is get it in standard form and try to what? Factor it. Try to factor it. If I recognize that it won't factor, then I'm going to see if I can use the square root method. I can make you a little note on the handout that might help you. You can use the square root method when the x to the first term is missing. I could not have used the square root method on this problem because I had an x squared and an x. I had that first degree term. If I took the square root of both sides, well, even if I got the x squared by itself, I'd be taking the square root of negative 6x on the other side. That won't work. You can only use the square root method when you're missing your first degree term, which was the case here. I didn't have my first degree term and I used the square root method. Here, you have to kind of think what it would be if you FOIL this out. You would have an x squared minus a 4x. So you have your first degree term. No, I'm sorry. Say like I didn't say that because I just messed up. You can take the square root of both sides because you just have something squared equals a constant. You don't have x squared or you don't have x's on both sides. All right. So when faced with any quadratic equation in the whole wide world, my first thought is try to factor it. If it won't factor, my second thought is, hey, see if I can use the square root method. But if both of these fail, there is an if all else fails method, and it's the quadratic formula. It would take you take me about 5, 6, 7 minutes to show you where this formula came from. And unfortunately, we don't have 6 or 7 minutes to spare. But to all of you who have learned somewhere in your life to hate the quadratic formula, it's a gift. You ought to try to solve quadratic equations without it. That's a pain in the butt. Somebody's already done the work for you and given you a formula that all you have to do is peel the coefficients off of your quadratic expression, substitute it into that formula, and then simplify as much as possible. Before we do this example 44, I need to show you two things about radical expressions. Let's say that I just want to simplify this expression. If I have 4 plus or minus square root of 8 over 6. We need to practice simplifying expressions like this so that when we use the quadratic formula and get an expression like this, we know the legal way to clean it up. The most illegal thing you could possibly do at this point is reduce that 4/6, and I see that a whole lot. What's wrong with reducing the 4/6? That 4 is a term, and in R.7 you couldn't cancel terms, so in 1.4 you can't cancel terms. You can only cancel things that are multiplied, factors. You cannot cancel terms or parts of terms. So the first thing you have to do is stave off that little voice, that little wrong voice inside you that's going, ooh, I can reduce that. The first thing you have to do is simplify that square root of 8. And you simplify a radical by thinking of the largest perfect square that'll go into 8 evenly. What factor of 8 is a perfect square? 4. All right. Now, you may write down another step, or you may just hold in your head the fact that 8 is 4 times 2. And so to simplify that radical, you take the square root of the 4 out of the radical and just leave the 2 under. Notice that I didn't take the 4 out of the radical. I don't have a 4 right here. I took the square root of 4 out of the radical and left the other factor. And that little voice is still screaming, ooh, ooh, reduce the 2 or the 4/6. You're just going to have to smack that little voice. It's wrong. That 4 is still a term. You can't cancel terms. You can only cancel what? Factors. So guess what you need to do in the numerator? If you can only cancel factors, then why don't you factor? Why don't you factor? You can factor. You know what? That's just like in R.7 if I had 4 plus 2x over 6 and told you to simplify that. You should know to factor out the 2. And then you can reduce, but not until you factor out the 2. Well, that same thing is still true in 1.4. You have to factor out a 2 and after you do, you can reduce the 2 and the 6. By realizing that 8 had a factor that's a perfect square, it's 4. So I wrote that 8 is 4 times 2. And I took the square root of 4, which is 2, out of the radical and left the other 2 under. Let's figure out what goes inside that parentheses. It was easy here. It's just a tiny bit uglier here. What do you multiply times the 2 to get this 4? 2. And then your plus or minus. And what do you multiply times 2 to get 2 square root of 2? Well, 1 square root of 2, or just square root of 2. If you're unsure of yourself in factoring, all you have to do is check it. 2 times 2 gives you this 4, and 2 times square root of 2 gives you this 2 square root of 2. I'm absolutely obsessive about checking factoring because it's one of the biggest ways to save yourself from making what you call silly mistakes and what I call, but your bridge will still fall in. I don't care if it's a silly mistake or not a silly mistake, your bridge still falls in. So check your factoring. Once you're sure that it's right, you can reduce that 2 into the 6 and have 2 plus or minus square root of 2 over 3. Now, one other thing I need to say about this problem, then we'll do our example. I believe that my math lab wants you to write your answers separately. Just like when the answers were 0 and -6, you wrote 0, -6. My math lab wants to see those 2 answers separated. That is 2 answers. One of them is positive 2, or excuse me, one of them is 2 plus square root of 2 divided by 3, and the other is 2 minus square root of 2 divided by 3. So in my math lab, you might have to take that apart and enter both answers separately. I don't think so. You can try it. Okay, and try it. Try it. If it works, then that's a shortcut. But if it doesn't work, that's how they want you to write it. That is the actual number. That's the exact answer. The only thing you could do to simplify it further is to get an approximation. Now, if you have to have the exact answer, that's the 2 exact answers. If a decimal approximation is good enough, then you could say, square root of 2 is about 1.4. 2 plus 1.4 is about 3.4. 3.4 divided by 3 is a little over 1. It's 1 point something. You could get a decimal approximation, but without approximating, you could not simplify that answer any further. Now, I thought I saw another hand. Does somebody have a question? Okay, I imagine that. Okie doke. Just do not engage in highly illegal canceling. Simplify the radical first, and then factor before you cancel. Let's look at number 44. If you just gave me that equation mixed in with a whole lot of other equations, the first thing I would need to recognize is, hey, that's a quadratic equation. How do I know? Because it has an x squared, not just an x to the first. That's the first thing I think is that's a quadratic equation. Right after I think it's a quadratic equation, and I notice that it's already in standard form, what's the first thing to try? Factoring. But are there factors of 1 that have a sum of 6? So that's not going to work. Second thing I think is, can I use the square root method? Can I? Not with that x to the first term. So I'm left with the if all else fails method, known as the quadratic formula. Now, the a, the b, and the c that are in the quadratic formula are just the coefficients of that expression in standard form. The coefficient of x squared is 1, so a is 1. B is the coefficient of x, and c is always your constant. Yeah. Yeah, and you can, instead of reading that as negative b, you can read it the opposite of b. Whatever b is, you take the opposite of it. And if no one has ever told you this, I'll let you in on a little secret. The quadratic formula can be sung to the tune of Pop Goes the Weasel. Some of you may know that, and that's great. But if you have trouble memorizing it and you have a closet opera voice, oh, I'm not even going to do my closet opera voice, but it just starts, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Y'all just leave me a tip at the door for that. When they were just little bitty babies, I would rock them and sing, the wheels on the bus go round and round, and Amazing Grace, and the quadratic formula to the tune of Pop Goes the Weasel. They just knew it by the time they were 3. Okay, plug it in. X equals, I'm going to start over here because this could take a little room. X equals negative b, that would be negative 6, plus or minus, that's where we get the 2 solutions, square root of b squared, that would be 6 squared, minus the number 4 is always in there, and if we had time, I'd show you why. 4 times a times c, all divided by 2 times a. Make sure your radical is long enough to cover the whole b squared minus 4ac. Make sure this division bar is long enough to see that all of that is divided by 2a, not just the negative 6. And then it's just simplify, simplify, till you can't simplify anymore. So, negative 6 plus or minus the square root. I can say 6 squared is 36, and 4 times 1 is 4. And I know you probably have this little voice just like I do. saying, ooh, 2 goes into 6, or -6, -3 times. Yes, that is true, but it's highly illegal canceling. That would be canceling a term. So don't do that. Instead, go ahead and say 36 minus 4 is 32. And then try to think of the largest factor of 32 that's a perfect square. 16. Now, this is kind of like simplifying fractions. If you're simplifying the fraction 4/12, you may not think, ooh, 4 will both go into them. You may only think, ooh, 2 will both go into them. But if you reduce that to 2/6, then you just have to reduce again. Same thing here. If you didn't think, oh, 16 will go into it, you may only think 4 will go into it. You're just going to have to simplify again. If you think the 16, though, that's 16 times 2. You can take the square root of the 16 outside the radical. Square root of 16 is 4. And that only leaves the 2 under the radical. And I'm still tempted to cancel this 2 and 6, or maybe that 2 and 4. But I need to factor. What can I factor out of the numerator? A 2. What will that leave inside the parentheses? -3 plus or minus, yes, 2 square root of 2. Good. If you're not sure, all you have to do is check it. It'll multiply to give you back what you started with.
So you just factor, when you're factoring out, just factor out the square.
Right. You cannot factor something out from beneath a radical. You can simplify by taking the square root, but you can't just factor a 2 out. No, no. Yes, sir. Mm-hmm. Taking the square root of, not squaring, but taking the square root of 16 and leaving the other factor under.
I wrote that down as -6 plus or minus the square root of 4.
You know what? In intermediate algebra, we have a whole day to talk about nothing but simplifying radicals, and that's wonderful. What we do, Wilson, is just what you said. First, we write the square root of 32 as the square root of 16 times 2. And then we break it into 2 radicals, square root of 16 times square root of 2. And then we take the square root of 16. Actually, that's not what you said. You said you still had the 4 under the radical?
Right.
Yeah, no. 4 is the square root of 16, and we don't take the square root anymore. But this is the middle steps that we learn in intermediate algebra, so that in college algebra we can kind of skip that and go straight to this. Ooh. Yeah, that would be illegal. That's fabulous. That's fabulous. But make sure your calculator is giving you the exact answer, not a decimal approximation. Yes, and some calculators will. If you type in -6 plus or minus square root of 32 over 2, it'll go straight to -3 plus or minus 2 square root of 2. And that's a fabulous button. But it's really not that much work to do if you don't have that button. No, cheap calculators do that now. All right. Again, you may have to separate that for my math lab into -3 plus 2 square root of 2. Mr. Kevin, I'm saying something so important. And -3 minus 2 square root of 2. But you don't have to give a decimal approximation unless the directions say. If the directions say give a decimal approximation, then punch on your calculator -3 plus 2 square root of 2 for one of your answers, and -3 minus 2 square root of 2 for your other answer. All right. This would be just a little bit uglier if our equation had fractions in it. But not panic uglier, because I already know how to clear out fractions. How do you clear fractions out of an equation? Multiply every term by the LCD, and what is the LCD of those two fractions? X squared. That's what x and x squared will both go into. So I need to multiply all 4 terms by x squared. The 4 has to be multiplied by x squared. The 1 over x has to be multiplied by x squared. I can write it x squared over 1 whenever I'm multiplying by a fraction. The 1 over x squared has to be multiplied by x squared. And technically, the 0 has to be multiplied by x squared, even though on the next line I'm just going to say 0 times x squared is still 0. I still just have 3 terms, though. This is one term held together by multiplication. This is a term held together by multiplication. This is a term, and that's a term. So my first term, nothing cancels. That's 4x squared. What does my second term simplify to? Yeah, this x goes into that x squared and leaves an x to the first. What does the third term simplify to? Just -1, and the right-hand side is still 0. Now I have a quadratic equation in standard form. So what's the first thing I try? I would try to factor it because I'm good at factoring. If you're not good at factoring, you can go straight to the quadratic formula if you want to. But this would be the hard kind of trinomial. I'd multiply 1 times 4. Are there factors of 4 that have a difference of this one? No. No factors of 4 that have a difference of 1. It won't factor. Could we use the quadratic formula? Excuse me. Could we use the square root method? Nope, have that x to the first term, can't use the square root method. If all else fails, use the quadratic formula. And here, a is 4, b is 1, and c is -1. So, x equals -b, or the opposite of b, those mean the same thing, plus or minus the square root of b squared minus 4 times a, which is also 4, times c, which is -1, all divided by 2 times a, which is 4. And then simplify and simplify till you can't simplify anymore. -1 plus or minus the square root. Be careful in this second term. Notice I have a negative times a negative. I don't care what the numbers are. A negative times a negative is going to give me a positive. And then I'm just going to multiply the 4 times 1 is 16. That would simplify to -1 plus or minus the square root of 17 over 8, period. I started to say 18, but it's just 8. What's wrong, Miss Courtney? Is it, why do you have a plus there? Okay. and then see if it'll simplify any further. Does 17 have a factor that's a perfect square? No. So the radical won't simplify any further. Is there anything I can factor out of the numerator to cancel with this 8? No. So it won't simplify any further. That's the answer. -1 plus or minus square root of 17 over 8. And other than separating the plus and minus, that's exactly what you would put in my math lab. But I do want to make sure that you understand that's not just some ugly expression that makes my math lab happy. It's two numbers that make that equation true. And you can get a decent estimate of those two numbers even without a calculator. Let me show you how you can get a decent estimate of that without even having a calculator. There are the two exact answers that you're going to type on my math lab. But square root of 17 is darn close to what? Darn close to square root of 16, and square root of 16 is just 4. So without a calculator, I'm just going to say, that's about 4. And 4 plus -1 is about 3. And 3/8, you might need a calculator there, but it's about, it just went away. I've got the 5/8 in my head, 4/8, 3/8, 0.375. It's about 0.375. I just know because I deal with 8s so much, I know that 1/8 is 0.125, 2/8 is 0.25, 3/8 is 0.375. It's just not that I can do division that quickly in my head, but I've worked with 8s a lot. What about -1 minus 4? -5. -5/8. It's about -0.625. Now, actually on the calculator, it might be 0.38 instead of 0.375, but that's a pretty good approximation for no calculator. You could take those, substitute them back into the original equation, and see that both of them make the equation darn close to true. Not exactly true, because that's not exactly what the answer is, but it'll make this darn close to 0. The only time that you have to give a decimal approximation is when you're doing a word problem where a decimal makes more sense. If I said, when is the ball 10 feet high, then -1 plus or minus square root of 17 over 8 doesn't make a lot of sense. Whereas, about 1/3 of a minute, that makes sense. All right. Another note. Look for the most efficient method to solve the equation. Now, if you're really bad at factoring, it may not ever be the most efficient method for you. You could use the quadratic formula on every problem. But being as you have to learn to factor for other things, you might as well practice your factoring here. First thing I notice about number 88 is it's a quadratic equation. What do I need to do? I need to subtract 1 from both sides because it's not in standard form. X squared plus x minus 1 equals 0. There's only one question you have to ask yourself to know whether or not that will factor. Are there factors of 1 that have a difference of 1? The only factors of 1 have a difference of 0, so it won't factor. Can I use the square root method? Has the first degree term. I can't use the square root method. If all else fails, I can always use the quadratic formula. In this problem, A is 1, B is 1, C is -1. Excuse me, just for the sake of time, I'm going to put Q, F, ... I just wanted to show you how to decide which method to use on each problem. with about 2 more minutes, you could finish that one up. Number 52, the first thing I notice is it's a quadratic equation. What's the first thing I need to do? Get it in standard form. First thing you need to do is get it in standard form. Don't try to take the square root of both sides. Don't even divide both sides by x. Ooh, that's a common mistake. Let me tell you why you can't divide both sides by x. Just over here as an aside, if I divided both sides by x, I would have 4x equals 5. And I would get one solution is 5/4. But I would think that that's the only solution, and it's not. There's another solution. Let's see where that other solution comes from. If we do this the correct way, we get it in standard form. Remember when I said it doesn't matter if your zero's on the left and right? I always try to move things to the side that will keep the coefficient of x squared positive. It's easier to factor something that starts with a positive 4x squared than a negative 4x squared. So on this problem, I would subtract the 5x from both sides, although technically it doesn't matter at all. And then what? You can factor out a GCF. Don't forget to look for a GCF. If you factor out an x, that will leave you x minus 4x minus 5. Give me one jiffy to come back to that question. I will. Now that you have it factored, set each factor equal to 0. And guess what? I get the 5/4. 5/4 is one of the right answers. But what else is a solution to that equation? 0. And I didn't get 0 using this method. Actually, this method is illegal. You can't divide by a variable unless you know for sure that the variable doesn't equal 0. Else you may accidentally be dividing by 0, and that blows up the universe. So instead of dividing by something that may equal 0, do that by factoring instead. Now, what about the question, do I need to add a 0 to the end? I don't need a 0 there in order to factor it, but if I was going to use the quadratic formula, I would have to think OC is 0. All right? So not if you're going to use factoring, but if you're going to use the quadratic formula, you'd have to realize that that's what C is. One more, 78. It's a quadratic equation. It's in standard form. Can I factor it? No. Can I use the square root method? It's missing the x to the first term. So you can use the square root method. You just need the square term on one side and the constant on the other. And then when you take the square root of both sides, bells and whistles go off to remind you, don't forget the positive and negative square root of 6. There are 2 answers.
You wouldn't write that as x.
Let me show you why. You're right that you can't.
That's what I was getting at the last time.
But let me show you why that could be done here and can't be done here. You can simplify 6 into, or not simplify, but you can factor 6 into 2 times 3, but you can't take the square root of the 2. Whereas here, when you wrote 32 as 16 times 2, you could take the square root of the 16. So this won't simplify any further because 6 doesn't have a factor that's a perfect square. You can factor it, but not into a perfect square. All right, one word problem, and yes, you do have one similar to this on the test. I think it's a little bit easier, but still you have one similar to this on the test. There are 2 word problems on the test. Remember, we had that one section on word problems, but the only kind we did was the mixture problems and the investment problems. There will be one of those 2 on the test, and then there will be one, when does the ball hit the ground problem. That's the most famous problem in algebra and in physics. An object is propelled vertically upward with an initial velocity of 20 meters per second. The distance in meters of the object from the ground after t seconds is given by this formula. Actually, I don't even consider this to be a word problem because I don't have to come up with the formula. They give it to me. Here's what's going on. Something is being thrown upward from the ground. It's going to go up, 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 up until gravity kicks in, and then it's going to start falling, and it's going to fall until it hits the ground. How would if I had a different question, if I wanted to know how high is this object in 2 seconds, how would I find that out? That's what the T stands for, time. The time since tossed or time since cannon fired, whatever it is. T is the number of seconds, so if I put 2 in the place of T and just punched it on the calculator, S would be my answer. And in physics, I don't know why, ask a physician, ask a person in physics, S stands for distance in physics. So if I put a 2 in place of the T and got an answer for that, that would be the distance the object is above the ground, also known as the height of the object. Now that would be a pretty easy question to answer. The little bit more difficult question to answer is, when will the object be 15 meters above the ground? Well, the very fact that the question begins when tells me that I'm solving for which one of my variables? Time. No, when is time, so I'm solving for t. This 15 is 15 meters. That's not 15 seconds. That's 15 meters. So that's what goes in the place of S. Notice I just put, and I typed this to make it a little faster for us, I put 15 in the place of S, and then I needed to get it in standard form. I could have just subtracted 15 from both sides, but because I like the coefficient of t squared to be positive, I added 4.9 t squared to both sides and subtracted 20t from both sides. Here's that equation in standard form. And I want you just to look at it a minute until I'm sure everybody understands where that equation came from. I was given this equation for finding the height, but if I'm given the height and I want to find the time, I just need to put that height in place of S. Here's 15 in the place of S, and here's what I got in standard form. Now again, the one on the test is not quite this ugly. You don't have to plug decimals into the quadratic formula, but with a calculator, that really shouldn't be a big deal. If A is 4.9, B is negative 20, C is 15, here's what you get when you plug that into the quadratic formula, and here's what you get when you simplify it a little bit. Now again, without a calculator, just think what this is close to. That's close to 20 plus, what's square root of 106 darn close to? 10. It may be 10.1 or 10.2, but it's very close to just 10. So it's close to 20 plus 10 divided by, what's 9.8 darn close to? 10. That's 30 divided by 10, or 3. Notice I'm saying approximately. Not exactly 3, but darn close to 3. And also 20 minus 10 over 10 would just be 20 minus 10 is 10, and 10 divided by 10 is 1. Are those meters or seconds or dollars or ducks? They're seconds. That's what T is. So the units on that 3 and 1 are seconds. I'm saying that the ball, the whatever, is 15 meters high at 3 seconds and at 1 second. How can there be two answers to when is the ball 15 meters high? Once on the way up and once on the way down. Maybe that's 15 meters right there. And so that's 1 second on the way up, and then it reaches the peak, whatever it is, and is 15 meters again at 3 seconds. Now, I want to tell you one other thing about punching this on the calculator. If you want a more precise answer than you can get in your head, you need to know how to type this correctly on the calculator. 20 plus, or let's just do the 20 plus square root of 106 divided by 9.8. The most important thing you have to know is that you have to have the numerator in parentheses or you won't get the right answer. Your calculator follows the order of operations. If you just say 20 plus square root of 106 divided by 9.8, what would the order of operations say that you should do first there? It'll do the square root and then divide. That's not what you want. What you want is your calculator to add and then divide. Now, depending on what calculator you have, some calculators you can just open the parentheses and say 20 plus square root of 106, close the parentheses, divided by 9.8, hit equals, and there's your answer. And sure enough, it's darn close to 3. But some of you, when you hit your square root button, the calculator automatically opens a parenthesis for you. Do any of you have that situation? All right. If your calculator automatically opens a parenthesis for you, you have to close that parenthesis before you close the parenthesis that you opened. You shouldn't have to, no, you don't have to open with a double parenthesis. You just have to close the parenthesis the calculator opened. You have to close with a double. You don't have to open with a double. So is everybody able to get something darn close to 3 on the calculator? What is it approximately? Boy, we were close. 3.09 seconds.
If we do that with other answers, instead of writing them out like that, it's possibly good.
Well, in my math lab, and anytime the directions say solve the equation, unless otherwise specified, I want the exact answer. And the exact answer is this. It's only if I say, give me a decimal approximation, that you use the calculator and get a decimal. Yeah. Is that what you were asking?
Yeah, you were talking about earlier, it's all about checking.
To check your answer, it would definitely be easier to substitute 3.09 in place of these T's than it would be this. But still, it just depends on what the person asking the question is wanting. If they want the exact answer, you give them this. If they say round to the nearest hundredth, then you give them that. If they say round to the nearest tenth, you give them 3.1. Yes, you would get 2. Right. All right. Now that problem actually has a B part and a C part on the back. The B part says, when will the ball strike the ground? Well, if you give me numbers to plug into an equation, I'm pretty good at that. But if you just say, when will the ball strike the ground, you haven't given me any number to plug into the equation. You didn't give me a value for time. You didn't give me a value for height. Or did you? When the ball hits the ground, its height is 0. So you just have to think, oh, that just makes sense if you think about it. If you're not in panic mode, then it makes sense that they did give you a value of S, and that's 0. So you just take the equation that was given to you, negative 4.9t squared plus, what was it? 20t? No, the plus 15 was just the A part when we were substituting in 15 meters. Yeah, the original equation. Oh, 20. I wrote 2. Okay. So that's our equation. Now, we could use the quadratic formula. If we did want to use the quadratic formula, what is the constant in that equation? 0. I'd have to say A is negative 4.9, B is 20, C is 0, because there's not a constant on the end. But that's not the easiest way to solve that equation. What should you try before you jump on the quadratic equation? Try to factor it. And the first question you always ask yourself when you're factoring is what? Is there a GCF? Is there a GCF? And yeah, there is a GCF. I can factor out a T here. It's not that you can't use the quadratic formula. It's that you'd make your life a lot easier if you realize that this will factor. And then you set each factor equal to 0. And you already have one of the times that the ball is on the ground is at 0 seconds because the ball started on the ground. But this other equation can be solved to find the other time that the ball's on the ground. Since it's a linear equation, just subtract 20 from both sides and then divide by negative 4.9. Without a calculator, tell me what that's going to have to be darn close to. 4 seconds. That's almost 20 divided by 5, so that's almost 4 seconds. Let's look at this picture again. If the ball was 15 meters at 1 second and at 3 seconds, when would it have hit this peak right here? Exactly halfway between 1 second and 3 seconds. So we didn't have to do algebra to figure that out. We could have done algebra to figure that out, but we didn't have to. Nor did we really have to use algebra to answer the B part, because if it takes 2 seconds to reach the top, how long does it take to reach the bottom? 2 more seconds, or 4 seconds in all. So common sense just confirmed algebra there. but you wouldn't have to use the algebra to find that approximately 4 seconds. What's making you frown, Kevin? Nothing? Okay, let me tell you something important about this formula. That is one of the most important, or one of the most famous formulas in physics, but if you get to physics and you read a problem that has that formula in it someday, you'll find out that it's not precise in the real world, because in small type beside it, it says neglecting air resistance. So anytime you see that formula, it works great if you're in a vacuum, but in real life, the results would be a little bit different, because you do have air resistance. That formula just doesn't take it into account. And sometimes there's not a 20. I mean, the only reason there's a 20 there is because this object started with a velocity of 20 meters per second. If it had been thrown upward with a velocity of 10 meters per second, that would be a 10. And the negative 4.9 is only when your units are in meters per second. If your units are feet per second, then that's a negative 16. But you don't have to memorize that. The formula is going to be given to you. You just have to know what to do with it. All right. C part leads us into section 2.3 rather well. When will the object reach a height of 100 meters? Well, just like we did in the A part, that means let S be 100 instead of 50. Get the equation in standard form. Plug it into the quadratic formula. Simplify and simplify until you get right here, and then go, whoa, what does that mean? What happens if I punch square root of negative 1,560 on the calculator? I get an error. My calculator can't do that, because I can't take the square root of a negative number unless I know about imaginary numbers. And that's what is in the next section. In terms of this problem, what would it mean? How would you answer the question, when is the ball going to be 100 meters high, if you came up with this as your answer? No. There's no real value of t or there's no time at which the ball is going to be 100 meters. The ball is not going to be 100 meters. It's not going to go that high. And we found out because the quadratic formula gave us an imaginary solution. So correct. So object will not reach 100 meters. It's just not going to go that high. Let me caution you about a common mistake on the test. There's a section that says solve the equation. And some of the equations give you real number solutions. Some of the equations give you imaginary solutions. If I say solve the equation, I mean whether it's real or imaginary, give me the answer. The only reason that I just quit right here is because this is a word problem where an imaginary answer wouldn't make sense. That means the ball's not going that high. But in another problem like these two, if I use the quadratic formula and I get an imaginary solution, I want you to write down that answer. Don't just write no solution and quit working. But I'm just a little bit ahead of myself. Let's go back right here. There's a math problem that drove mathematicians crazy for a few hundred years. And that math problem is this. Solve that equation. Well, for a long time, mathematicians didn't worry about it at all. They just wrote no solution. There is no number you can square and get -1. And they were almost right. There's no real number you can square and get -1, but Leonhard Euler, I don't remember what century it was, I think 1600s, suggested that there are numbers that aren't real numbers, and believe it or not, they have applications in the real world. Now, if I had invented them, they would be not called imaginary numbers, because that sounds like Barney made them up. I would have called them, if I'd invented them, I'd have called them the Milesian numbers or something. But it would sound a little less fake if it wasn't called imaginary, but it is what it is. Huh? They can't be totally fake if they are solutions to problems in the real world. I had a student one time who had been in the Navy for 6 years working on a nuclear submarine. And this is almost the most excited I've ever seen a student in my class. The day that I told him what I was, I thought he was going to lose his mind. He said, that's what I did in the Navy for 6 years. And, they just tell on the need-to-know basis. You didn't need to know what it was. You just needed to know how to use it. He knew how to use it. He'd been working with eyes for 6 years without even knowing what I was. And so there are applications, primarily in physics, in electrical engineering. Imaginary numbers have applications in nuclear fission. Imaginary numbers have real-life applications. Most of us don't need them. I've never needed one in Walmart. All right, but let's talk about what they are. The imaginary unit is a symbol that Leonhard Euler said, to solve this problem, we just need a new kind of number. Let's call it I. And define I to be the square root of -1. That opened a whole new field of mathematics. All of a sudden, mathematicians could do things they could never do before. And most of us don't need to do. I is the square root of -1. And if you square both sides, you get I squared is -1. I is the solution to that equation. It makes the equation true. So what do you do with it? Well, if we have, for example, if we're using the quadratic formula and we come up with square root of -36 as part of the quadratic formula, up until now, I would have just written not a real number. But now I realize I can write that square root of -36 as the square root of 36 times the square root of -1. I'm just breaking the negative apart by factoring. The square root of 36 is just 6. And the symbol we use for the square root of -1 is I. So the square root of -36, we're no longer just going to put not a real number. We're going to write the answer in terms of I. And notice that's not the same thing as -6. If it was just -6, then we wouldn't need an I. It's not -6. It's 6 times the square root of -1. What about this? A square root of -24. Well, 24 is not a perfect square, but it has a factor that's a perfect square. What is it? 4. As a matter of fact, I can factor that square root of -24 into -4 times 6. And then without having to write in another middle step, I can just say the square root of -4 is not 4i, but 2i, and only leave the 6 under the radical. Now, since all of that's held together by multiplication, It also means the same thing if you write 2 square root of 6 times I. But the reason that I always write my answer this way is because if I write it this way and you're copying it down, some folks make their radical too long and it looks like I is under the radical. It's not. It's not square root of I. That's a whole other thing. It's just 2 square root of 6 times I. So you, yeah. If I had written another step, Courtney, this would be it. Square root of -4, or excuse me, square root of 4 times the square root of -1 times the square root of 6. All right. So we talked about imaginary numbers. Complex numbers is the biggest set of numbers in the universe. We've talked about a lot of kinds of numbers now, and if we had time, I would go back through and remind you about whole numbers, integers, rational numbers, irrational numbers. But all of those that we have ever talked about up until 15 minutes ago, all the numbers we'd ever talked about were real numbers. Now we know that outside that set of real numbers, there's a set called imaginary numbers. Those two sets put together, the real and the imaginary together, make up the biggest set there is, the set of complex numbers. Any number in the universe can be written in the form a plus bi. My printer wasn't working well this day. A plus bi, and have a real part and an imaginary part. For just a real number, like if I said write 7 in this form, I would never ask you to do that, but if I did, it would just be 7 plus 0i because it didn't have an imaginary part. What about this? 5 minus square root of -49. All you need to do is tell me that square root of -49 is 7i, and then there's your complex number, where 5 is the real part, -7i is the imaginary part. Just bring it down. Yep. So real quickly, and we may not have time to do both of these examples, but let's definitely do one of them. Number 58 is a quadratic equation. I'm playing like I don't know this yet, but actually I do know I'm going to come up with an imaginary solution. First thing I'd try to do is factor it. Are there factors of 8 that have a sum of 4? No factors of 8 that have a sum of 4. 4 and 2 have a sum of 6. Won't factor. Can I use the square root method? Can't use the square root method. The if all else fail method is the quadratic formula. So A is 1, B is 4, C is 8. In the quadratic formula, that would give me -4 plus or minus the square root of 4 squared minus 4 times 1 times 8, all divided by 2 times 1. Under the radical, look up just a second. Under the radical, that's just 16 minus 32. So to save time, I'm going to go ahead and say it's -16. The most illegal thing you could do at this point is cancel that 2 and that 4. That would be canceling a term. You can't do it. You have to simplify the radical. Square root of -16 is 4i. It's still tempting to engage in highly illegal canceling there, but don't. What else do you have to do? Factor a 2 out of the numerator. Actually, you could factor a 4 out of the denominator, and that would be, or out of the numerator, and that would be fine. I only factored out a 2 because that's all I was going to get to cancel. But it's, it would be okay if you factored out a 4. You'd just have something left outside parentheses. If that's the solution to a word problem, when does the rocket reach the moon? The answer is the rocket's not going to meet the moon. But in some applications, there are folks who can do something with that answer. All right, you get the 30-second version of my practice test sermon. Folks, I do not understand people who come in here Monday to take the test when the highest they've made on the practice test is a 40. If the highest you make on the practice test is a 40, then you will make a 20 on the real thing. If you don't believe me, try it. Even if you work on it until you make 100 on the practice test, you still might only make a 90 on the real thing, but that's okay. An 80 is okay. Do not come in here Monday without having taken that practice test over and over until you've done very well on it, and very well without having to look at notes or phone a friend. There are actually 2 resources you can use to prepare for this test. This is so important, Harley. There are 2 things that you have. The My Math Lab practice test is the one that counts as part of your course average. It matters. But if you look in Momentum, there's also an optional practice test. Do them both. That practice test right now, it's in your upcoming assignments box. If you click on it and work in it and you don't get through, but you have to leave, just exit. It will save what you've done and you can come back into it later. It's not going to grade until you click submit. All right. So say you go and you click on it and it opens and you do the whole thing and then you hit submit and you've made a 60. You need to do it again. But it's no longer in your upcoming assignments box. It is still on the left-hand column. It says assignments. If you click on assignments, you'll still see it.